Hello, my name is Casey Clements. I'm an assistant professor of chemistry at Tidewater Community College. In this presentation, we'll help show you about what chemistry can find in the wetlands. In this presentation, we'll talk about 4 main examples of chemistry in the wetlands, even though there are many more. We'll talk about dissolved oxygen, salinity, nitrates and phosphates, and finally pH. For each of those examples of chemistry, we'll talk about 4 main questions. We'll talk about what it is, why do we care about measuring it, how do we measure it, and what questions should we keep in mind about it while we're out in the field. The first chemistry concept that we'll be discussing is dissolved oxygen. Dissolved oxygen is often abbreviated as DO. It is a measure of how much oxygen gas is dissolved in your water sample. Dissolved oxygen is very important because it has a direct impact on water quality. If there is not enough oxygen dissolved in the water, life cannot be supported, and this can lead to a fish kill. We'll be measuring dissolved oxygen using a digital probe. That probe first needs to be calibrated for temperature. So before heading out into the field, make sure that you calibrate your dissolved oxygen sensor. For more information on the probe, I've included a link. That link shows you the user manual, so you can have more information about the probe before you use it. When you're measuring dissolved oxygen, here are a few questions you need to keep in mind about it. What connections occur between the dissolved oxygen and the temperature? And what about between the dissolved oxygen and the atmospheric pressure? What connections are there between dissolved gases and water quality? How does it affect the life? How do these gases even become dissolved? And what factors influence that? And how does the amount of gas dissolved vary in different locations? And what does that mean in terms of the life? For more information, here are 2 links you can visit to learn more about dissolved oxygen. The next issue we'll be discussing is salinity. Salinity is a measure of the total amounts of salts, or in other words, ionic compounds, that are dissolved in a water sample. Average ocean salinity is around 35 parts per thousand, and freshwater salinity is typically less than 0.5 parts per thousand. Where they're mixing, the salinity value can range from around 0.5 to 17, and that's what we consider brackish water. We care about salinity because it can give us an idea of how ocean water and freshwater are mixing, and of how that water is circulating based on the salinity value of the sample. Aquatic plants and animals can only thrive within a very narrow range of salinity. So that means that if you're sampling different areas that have different salinity values, they'll support different species. And also, if the salinity of an area changes, that can disrupt the plant and animal life that is specialized for that salinity value. Salinity can also reduce the amount of dissolved oxygen that can be found in that water sample, and that has a further impact on the aquatic life. Salinity can be measured in a variety of ways. You can either use a salinity probe, conductivity probe, or a refractometer. I have a link here to salinity and conductivity probes, including their user manual, so you can read up on how to use them. A refractometer measures the salinity based on how much the light is refracted. When you're measuring salinity, here are some questions you need to keep in mind. How does the salinity level vary at different locations and temperatures? And how does that affect the life that's found there? For more information, here are 2 links you can visit to learn more about salinity. The next issue we'll be discussing are nitrates and phosphates. Nitrate and phosphate are nutrients that are required by living organisms, but if you have too much of it, it can be harmful. The main sources of nitrate and phosphate can come from natural sources like precipitation, or the dissolving of minerals from soil or rocks. But it can also come from human sources, such as fertilizer use and overflow from sewage treatment plants. We care about nitrate and phosphate because they're required for aquatic life, but in excess amounts they can be very harmful. If you have too much nitrate and phosphate in the water sample, it can lead to algae blooms, which will lower the amount of dissolved oxygen in the water and lead to fish kills. Nitrate and phosphate in the water can be measured using a Lamont kit. This can be done with ocean water, fresh water, or soil samples that have been dissolved into water. When you're measuring nitrates and phosphates, here are some questions you should keep in mind. How does the amount of the ion dissolved vary in different locations? What could be causing this variance? And how does that affect life in the different areas? And for more information, here are a couple links you can visit to learn more about nitrate and phosphate. And the final aspect of chemistry in the wetlands we'll be discussing is pH. pH is a measure of an aqueous solution's acidity or basicity. pH typically ranges from 0 to 14. To mathematically calculate pH, it's the negative log of the hydrogen ion concentration. If we have a pH of 7, it's considered to be neutral. In a neutral sample, we have as much hydrogen ion concentration as hydroxide. In solution, hydrogen ions bond to water to form what's called hydronium, H3O+. So in a neutral sample, we have as much hydronium as hydroxide. If we have a pH value below 7, we call that an acidic solution. In an acidic solution, we have more hydronium than hydroxide. If the pH is above 7, we have what's called a basic solution, and here we have more hydroxide than hydronium. Clean rain pH is around 5.6. It is slightly acidic due to CO2 from the atmosphere dissolving into the water, forming carbonic acid. Common fresh stream pH is around 6.5 to 8, and common ocean pH is around 8. We care about pH because most fish survive best in a pH range of 6.5 to 8.5. If the pH level rises above this or below, fish can start to die. Different species have different pH tolerances, but anything really below 6.5 or above 8.5 can lead to fish species dying off. Very low pH levels accelerate the leaching of metals into the water, which can have a negative impact on the aquatic life. And also, as the pH level decreases, carbonate becomes less available, which can negatively impact coral, mussels, snails, plankton, and many other species which require carbonate. pH can be measured using either a pH probe or pH test paper. For more information on the probe, I've included a link to a site that includes its user manual. When you're thinking about pH, here are some questions to keep in mind. What factors affect the pH of water? What does pH really mean, and what are you really measuring? And also, how does the pH vary between different locations? And what does that mean in terms of the water quality? And for more information, I've included a link here you can visit. Hopefully this has given you a good overview of what types of chemistry you can expect to find in the wetlands and what things you should keep in mind while investigating these factors.